Advanced Anatomy of the Respiratory System for 3rd semester Medical Faculty. Anatomy of the Respiratory System. A respiratory tract. The respiratory tract consists of structures that facilitate the transport of air to the lungs. It is divided into two main sections, the upper respiratory tract and the lower respiratory tract. 1. Upper respiratory tract. Function. Regulates incoming air by filtering, humidifying, and warming it before it enters the lungs. 1. Nose. External structure composed of cartilage and nasal bones. While the nasal cavity is lined with mucosa. Functions. Filters air using hairs, vibrissae, and mucus. Warms air via blood vessels in the nasal mucosa. Humidifies air before it enters the lower tract. Contains olfactory receptors to detect smells. 2. Pharynx, throat, a muscular tube located behind the nasal cavity and mouth. Divided into 3 sections. 1. Nasopharynx, upper part behind the nose. 2. Oropharynx, middle part behind the mouth. 3. Laryngopharynx, lower part connected to the larynx. Function. Conducts air from the nose to the larynx and food to the esophagus. 3. Larynx, voice box, located below the pharynx, connecting it to the trachea. Contains vocal cords responsible for sound production. Functions. Serves as an air passage. Prevents food from entering the airway via the epiglottis, which closes the larynx during swallowing. 2. Lower respiratory tract. Function. Transports air from the larynx to the lungs and facilitates gas exchange, oxygen and carbon dioxide, in the alveoli. 1. Trachea, windpipe. A hollow tube surrounded by C-shaped cartilage rings to prevent collapse. Lined with ciliated epithelial cells and mucus to trap dust and debris. Function. Provides a secure airway to the bronchi. 2. Bronchi. 2 main branches of the trachea, right and left bronchi, leading to each lung. The right bronchus is shorter and wider than the left. Function. Transports air from the trachea to the lungs. 3. Bronchioles. Smaller branches of the bronchi without cartilage, surrounded by smooth muscles. Function. Regulate airflow to the alveoli by contraction and relaxation. 4. Alveoli. Small sac-like structures at the ends of bronchioles. Lined with epithelial tissue and surrounded by capillaries. Function. Main site of gas exchange. Oxygen enters the blood from the air. Carbon dioxide is released from the blood to the air. B. Lungs. The lungs are the primary organs of the respiratory system, responsible for gas exchange between air and blood. 1. Structure of lung lobes. 1. Right lung, divided into 3 lobes, superior, middle, and inferior. Larger than the left lung due to the heart's position on the left side. 2. Left lung. Divided into 2 lobes, superior and inferior. Contains a cardiac notch to accommodate the heart. 2. Pleura. The pleura is a double membrane lining the lungs and thoracic cavity. 1. Visceral pleura. Directly adheres to the lung surface. Function. Protects the lungs from friction. 2. Parietal pleura. Lines the thoracic cavity walls. Function. Maintains the lung's position within the chest cavity. 3. Pleural cavity. The space between the visceral and parietal pleura, containing pleural fluid. Function. Reduces friction between the lungs and chest wall during breathing. C. Breathing mechanism. Breathing occurs in 2 main phases: inhalation, inspiration, and exhalation, expiration, controlled by pressure changes in the thoracic cavity due to respiratory muscle movements. 1. Inhalation, inspiration, function. Draws air from the environment into the lungs. Process. 1. Contraction of respiratory muscles. The diaphragm contracts and moves downward, flattens. Increasing thoracic cavity volume. External intercostal muscles contract, lifting the ribs upward and outward. 2. Increase in thoracic volume. Leads to a decrease in intrapulmonary pressure, pressure inside the lungs. 3. Airflow into the lungs. Air flows into the lungs as intrapulmonary pressure is lower than atmospheric pressure. 2. Exhalation, expiration, function. Expels air from the lungs to the environment. Process. 1. Relaxation of respiratory muscles. The diaphragm relaxes and returns to its dome shape. External intercostal muscles relax, lowering the ribs. 2. Decrease in thoracic volume. Leads to an increase in intrapulmonary pressure. 3. Airflow out of the lungs. Air flows out of the lungs as intrapulmonary pressure exceeds atmospheric pressure. 3. Passive versus active breathing. 1. Normal breathing, passive. Expiration occurs passively due to lung elasticity and muscle relaxation. 2. Deep breathing, active, during physical activity or coughing, additional muscles contract. Internal intercostal muscles compress the thoracic cavity. Abdominal muscles push the diaphragm upward to expel air quickly. 4. Regulation of breathing. Control centers. Located in the medulla oblongata and pons, which monitor oxygen, carbon dioxide, and blood pH levels. Responses: increased carbon dioxide levels. Stimulates faster and deeper breathing. Decreased oxygen levels, detected by chemoreceptors, triggering rapid breathing. 5. Lung volumes and capacities. 1. Lung volumes, tidal volume, TV. Air volume inhaled and exhaled during normal breathing, approximately 500 milliliters. Inspiratory reserve volume, reserve, additional air volume that can be inhaled after normal inspiration. Expiratory reserve volume, ERV. Additional air volume that can be exhaled after normal expiration. Residual volume, RV. Air volume remaining in the lungs after maximum expiration. 2. Lung capacities, vital capacity, VC. TV plus ERV plus ERV. Total lung capacity, TLC, VC plus RV.